Okay, let's get started here on chapter 5. It starts with something called the law of sines, and the question here is we're looking at this diagram and it says which angle is the biggest. And as we've discussed before, in geometry and trigonometry, you don't want to go just by how things look. I mean, because you could look at this and tell, you know, that gosh, there's an angle right there that looks like it's the largest. But we want to back that up with how do you know. So if you need to pause the video for just a second and think about it, you know, which angle is the biggest and then why. And then when you come back, we'll take a look at this. So it's pretty obvious on this problem that this angle right here is the biggest. So beta is the biggest, but the big concern is how do we know that that's the biggest angle? Well, take a look at the sides here. We've got side C that corresponds to gamma. Side C is 6 units long. Side A that corresponds to angle alpha, and it's 7 units long. And then we've got side B that's 10 units long, and it corresponds to angle beta. So beta is the biggest one, and here's why. We know it's the biggest one because it's opposite the largest side. That's why. And I like to think of things in terms of this. There's a theorem in geometry that says the larger the angle, the larger the side opposite. I like to say it this way, that a bigger angle cuts a bigger side. And when I say cut, it means the opposite side, or the one across from it, is created by the angle. So if here's angle beta, it creates or cuts this side out right here from kind of an auxiliary line right there. All right, so the larger the angle, the bigger bite it's going to take out of here. And the smaller the angle, the smaller the side it's going to create. So this is the biggest one. Angle beta is the biggest one. Since side C is the smallest, this would be the smallest angle, and this would be the medium one here. So this would be big, this would be medium, and this would be the smallest of the angles right there. So it stands to reason that the opposite side is related to the angle that created it. So again, this analogy that if I take a larger angle, it's going to take a bigger slice out of this side. If I've got this side right here, if I've got a smaller angle, it's going to create a smaller side, and so forth. So the interesting part about making this type of argument is that we can now make some adjustments to the trigonometry that we've been learning. So up until now, we've only been able to do right triangle trigonometry. They had to give us a right triangle, or we had to make a right triangle in order to use the trigonometry that we've learned. Now, since the sine function relates the size of an angle with the opposite side, so opposite over hypotenuse, has something to do with the opposite side, and we're going to kind of exploit that relationship. And what we mean by that is the way it's related is the bigger the angle is, the larger the value of the sine ratio. And I've got an asterisk by this because if you think about that for acute angles, that's definitely true. If I have a really small angle right here, the side opposite is pretty small. If I let that get larger and larger and larger, okay, this is a pretty big angle right here. But think about what happens when that kind of drops over the other side and it gets to be an obtuse angle. We end up with some interesting things that are going to cause some problems in just a little bit. So the law of sines is actually pretty easy to work with. Here's what we do. We take advantage of the fact that, again, the opposite side is related to the sine ratio. So here's what the ratio is. It's the sine of alpha over angle A, or side A, the sine of beta over side B. And so if we think about how these are related, angle alpha, side A, angle beta, side B, this is going to be angle gamma and side C. And the cool thing about this, just using properties of proportions, because that's what this is, you could take each one of those fractions and flip it over. So we could do A over the sine of alpha, we could do B over the sine of beta, and we could do C over the sine of gamma. Now, because you can use this in two different forms, we just want to make sure that the sides are always on the top and the angles are always on the bottom for each one of these three. And if we use this one right here, again, all angles on the top and all sides on the bottom. You don't want to switch those, okay? Now, because you've got a choice, it's usually easier or usually best to have the unknown quantity, whether it's an angle or a side, in the numerator. That just makes it a little bit easier to solve the resulting proportion or the resulting equation. So let's take a look at what we've got here. On the first example, it says solve the triangle, and you'll notice that what they've given us, and we've got a diagram on this one, and you have some problems on your assignment that give you a diagram. We've got two angles right here, and we've got one side. And if you remember from geometry, the way we'd name this situation is we go by the consecutive information that we've got. We have an angle here, then an angle here, and then a side here. So we call this angle, angle, side. And if you think about it, if they give us two angles on a triangle, it's really like they gave us all three of them. Okay, so we could quickly figure out what this one is. So gamma is going to be equal to 180 minus 72 minus 64. So if we do the math on that really quickly, we'll figure out that this side, this angle right here is 44 degrees, okay? So gamma is 44 degrees. So I've got all the angles, but remember when we solve a triangle, we have to find all the angles and all the sides. So what we do is we take advantage of this relationship right here. I know that that angle corresponds to that side right there, and I'm missing these other sides over here. So what I do is I say, now if I've got, and we'll call this alpha, if I've got that angle alpha, and there's beta, and it corresponds to that one, but I'm looking for a side, here's what I'm going to do. I'm going to put 13.6 on the top, sine of 64 on the bottom, and then I'm going to put side B over here over the sine of the angle that created it. So that's 72 degrees right there. Okay? And then I go ahead and solve this. And again, this is the nice thing about putting the unknown quantity up here. All I need to do to solve this is I'm going to multiply both sides by the sine of 72 degrees. So it would cancel there, leaving me B equals sine of 72 degrees times 13.6, which I'm going to move out front. And then we're going to divide that by the sine of 64 degrees. So we'll go ahead and pull up the calculator and we'll throw that in. Again, you'd want to make sure that you're in degree mode. So let's go ahead and do that. Check the mode. We are in degree mode. And let's type this in. And just to be on the safe side, I'm going to put 13.6 times the sine of 72. Put all that in parentheses, and then I'll divide by the sine of 64. Parentheses there. And I get 14.39. And just for the heck of it, 14.391. We'll go to the nearest thousandths place, 14.391. Now again, pay attention to the instructions. Make sure you do it according to those. If it says round to the nearest tenth, then of course this would be 14.4. You wouldn't want to use that rounded answer to produce this other one over here. So in order to find side C, I'm going to set up the same relationship. So I'm going to do C over sine of 44 degrees is equal to, and again, I'm going to use this one where I have both of those quantities, no rounding or anything like that, 13.6 and sine of 64. Multiply both sides by the sine of 44 degrees. Now the cool part about this is if you're using one of these calculators, I can just recall that command because look at the similarity between these two expressions. Right here and right here. So C equals 13.6 times the sine of 44 over the sine of 64, 13.6 sine of 72 over sine of 64. So very similar format. All I need to do is just recall that command, and I'm going to change this to 44 degrees. Hit enter, and I get 10.511. So 10.511. Okay, so the missing angle was 44 degrees. The two missing sides, side B was 14.391, and side C was 10.51. So we're all set to go there. Now, if you're given a problem that doesn't have a diagram, then you've got to be a little bit more careful. So it's usually good to draw things, roughly to scale. Now we've got angle alpha. So we've got angle alpha that's about 28 degrees, so about 30 degrees or so. Angle beta that's 66 degrees, and then side C that's 8.2 degrees. So let's think about how this would have to play out. Let's draw this roughly to scale. I'm just going to draw a side there so that I can draw an angle of about 30 degrees. So that's about 30 degrees. So there's my 28 degrees, and that's side or angle alpha. Then 66 degrees, that would be beta. I'm going to put beta on here about like this. So 66 degrees, so about like that. So this is roughly how I'd have to draw this. So this would be 66 degrees. That's beta. That makes this side B, that makes this side A, and then we know where this one has to be. Well, this has to be 8.2, and that means we're missing angle gamma. And again, if we think in terms of what we're given and we write it down consecutively, this was an angle, and a side. This isn't angle, angle, side, but it is this, angle, side, angle. Okay, so hopefully these things are ringing a bell from your geometry course in the past. So this is what we've got right here. But then now we need to think about this. I don't have any of the, this is the side I have, but I don't know what that one is. But remember, if they gave us two angles, it doesn't matter what order, we can figure this one out right here. So gamma is going to be 180 degrees minus 28 degrees minus 66 degrees. So we're going to end up with, let's see, 86 degrees. So that angle right there, and I'll label that on the inside, that's 86 degrees, and that's angle gamma. So we've got that one taken care of. Now we're just missing the two of these, and let's see how we'd set that up. I'm going to take A over the sine of 28 degrees, and let's think for just a second. I'm missing side A, and I want to set it up with a corresponding side and an angle. So I'm going to use 8.2 sine 86 degrees. Those correspond, so I should be in good shape there. And I'm also going to set one up for B at the same time. So this is going to be B over the sine of 66 degrees should be equal to, again, I'm not going to use A because that's going to have some rounding in it. I'm going to use the one that I've got all the information on about that correspondence, sine of 86 degrees. So you'll notice that in both cases, here's how I'd solve this. This is going to be A equals 8.2 sine of 28 degrees over sine of 86 degrees. This is going to be, side B would be 8.2 sine of 28 degrees over the sine of 86 degrees. Now, it might be worth it to take some time and think about what type of answers we're going to get on this. So if we look at this diagram right here, again, let's talk about that whole bigger sides, got bigger angles and so forth. This is the biggest angle, so that's going to be the biggest side. This is the smallest angle, so A better be the smallest side. We're expecting a fairly small side here, and then this one should be somewhere in between whatever we get for A and whatever we get for, or whatever we got for C. So I'm going to clear that off, and again, I'm going to type this one in here. So this is going to be 8.2 sine of 28. I know I'm in degree mode. And then I'm going to divide, again, because this is all multiplication and division. It would be on the safe side to put parentheses, but we don't really need it here in this particular case. So 86, close the parentheses, and I'm going to get 3.859. 3.859. Now, since this expression is almost identical, I'm going to recall that. And all I need to do is change this to, that needs to be 66 degrees. I apologize for that. Yep, 66 degrees there. Okay. And we'll pull that guy up. So 66 degrees. And we get 7.519. Okay. So this side right here, 3.859. And this side right here, 7.509. And again, we notice medium angle, medium side, large angle, large side, smallest angle, smallest side. Okay, so I think we're in good shape there. Okay, now let's move on and let's talk about some more interesting things that can happen here. And this is where the law of sines, although it's a pretty simple relationship, we can get to some interesting questions here. So the word here is ambiguous. So think about what the word ambiguous means. You may have heard that before. What ambiguous means is that things are unclear. So if I gave an ambiguous explanation, or you were in an ambiguous situation, you wouldn't be quite sure about what's going on. It wouldn't be very clear. So we do have to be careful. We've covered some fairly easy cases here where we had angle, angle, side, and we had angle, side, angle. We could draw a picture, or there was one already for us. But what if we're given an angle, a side, and another side? So you'll remember the nice thing about the two previous cases is they gave us two angles. It was easy to figure out what the third angle was. But what if they gave us only one angle and then a side and another side? Well, in that case, you're going to need to be really careful. And it's no wonder. Look at the abbreviation. You'd have an angle, a side, and another side. Now, in middle school and junior high, we kind of make fun of that. And yes, I did just write ASS there. But if you're given an angle and a side, you really have to be careful. And here's why you have to be careful, because there are 4 different outcomes. And you've got to check for each one of them, but we're going to kind of come through a process here where we can figure out which one it is. So let's run through the cases. We can end up with no triangle at all. Yep, they could give us information that doesn't even produce a triangle, so we'd want to be aware of that. We can end up with one right triangle, okay? We could end up with 2 triangles. One would, so that's going to be this picture right here. Or we can end up with one triangle that's not a right triangle. And it might be an acute triangle or an obtuse triangle. So we really got to be on our toes with this. And let's talk about why, if you're given an angle, a side, and a side, why you have to be really careful about this. So I'm going to make this a little bit bigger. Okay, and we're going to take a look at this. So here's what we've got. So we're given this angle right here. So that's the angle that we're given. We're given this side right here and then the side across from it. So here's our angle, our side, and our side. And that's why the diagram's set up like this. So I've got this long horizontal side right here. Not sure how long it is because we're not given that side. This angle is set. This side is set, and this side right here is set. And the way you want to picture this is, imagine that this right here is just a hinge, and we can swing this side right here back and forth like this. Well, this one right here would swing around, but it would never come down here and touch this side. Okay? So this side A is too short. Okay? So if we think of this right here, and they've labeled this H for a reason, we'll call this the height from here to here, or it's the altitude. And the reason it's we don't have a triangle, so A is too short because A is less than H. So if I know how far it is from here to here, if A is less than that, it's not even long enough to come down here and touch. Well, let's deal with the next case. So that's when we have no triangle, and we'll need to be on our toes for that one. Let's take a look at the next one. So again, here's the angle, here's the side, and here's the side we're given. Well, notice how A compares to H. Side A is just right. It's just the right size so that we can make a right triangle, and that's because A is exactly equal to H. So if A, this side that we're given over here, is less than this height, it's too short, so we're not going to have a triangle. If it's exactly the same as that, it's going to be just the right size, so we're going to have one right triangle. And then let's take a look at the most difficult case here. Let's say that side A was a little bit longer than H. So just a little bit. Let's say it swung down to about right here. Well, what I can do is I can swing it 2 directions. I can swing it out here and get a triangle like that, or swing it in here and get a triangle like that. And the way you want to think of this is if it's a little bit longer than H, swing it out here, we're going to solve for this triangle right here, and then swing it in here, we're going to solve for that triangle right there. So A is long enough to make one, and this right here would be an acute triangle. And one, look at this right here, that angle right here would be an obtuse triangle, okay? And the reason for that is it's a little bit bigger than H, but it's also smaller than side B. And you're gonna wonder, well, why would we worry about what B is? Well, we're gonna take a look at what would happen if A was bigger than B. So let's say this is really long, okay? Clearly longer than this side over here. Well, I can always swing it out on this side, okay, to make that type of triangle right there. But what would happen if I swung it out here, okay? Well, my only option is to swing all the way around and run into this side over here, okay? So there's only one triangle over here. It could be obtuse, it could be acute. And every year I get somebody who says, well, wait a minute. couldn't you do this? Couldn't we swing it up here and then stop right there so that we're dealing with this triangle right here? Let me highlight that one. Couldn't we do that right there? And the answer to that is no, and if you think about it, there's a good reason why. For this triangle right here, where is angle alpha? It's not inside the triangle, it's outside the triangle, and that's why we can't have that. So side A, in this particular case, A is too long, so there's only one way we can make a triangle, and the reason for that is because A is bigger than B, okay? So in all of these other cases, so A is less than H, A is equal to H, A is a little longer than H, but still smaller than B. And this one right here, all we need to check is if A is bigger than B, okay? All right, had to pause there for just a second. So let's come back here and we can go ahead and flip the page over. So again, what we're going to have to do first is we're going to have to figure out what H is and then compare side A. Unless we set up a diagram and we know for sure that A is definitely bigger than B, and then we can go for this case right here. So let's take a look. Now, if you'll follow this process and do it this way, I think you'll find that this is the easiest way to make sure you get it right, because on most of these, they give you the angle, the side, and the side, but they don't give you a diagram. And that's on purpose because they want to see if you know if there's going to be one or none or two triangles and what the case is there. So here's what I'd like you to do. First thing you're going to do is you're going to draw a long horizontal line. All right. So we'll draw a long horizontal line right here, like this. And then the next thing we're going to do is we're going to look at this and we're going to draw the acute angle, and it happens to be the only angle, and almost always it's acute, but I am going to look at an example here where it's obtuse, and we'll think about that one. Those are kind of interesting. And we're going to draw that, again, roughly to scale, okay? So we're going to draw the acute angle and the adjacent side. So about 41 degrees, so I'm going to make it look like this. So this is 41 degrees, and the adjacent side. So let's think about this. If this is angle alpha and this is side B and that's side A, well, side A has to be over here. So it's not going to be that one right there. This side next to it's got to be 5.4. And if you need to take a second to think about why that would be the case, go right ahead. Okay? So the next thing we do is we figure out what would H be. And that's actually a pretty easy calculation because the sine of 41 degrees should be equal to H, that opposite side over here, over the hypotenuse of 5.4. So that means H is going to be equal to 5.4 times the sine of 41 degrees. So let's grab the calculator and let's figure out what we've got here. Okay, and again, we're sticking with this process right here. Find out how long H would need to be in order to make a right triangle. So in other words, drop that straight down there. Okay, so I'll clear this off. 5.4 times the sine of 41 degrees. Can close the parentheses or not. We end up with 3.5. So 3.542. So this is 3.542. From here to here, it's 3.542. Well, let's look what we've got here. Side A is 3.3. So side A would be about that long right there. It would dangle around right here. It's not long enough. It's not longer than H. It's not bigger than H. So there's no way we can bring this down here and touch that side. So we have no triangle. Okay? And we kind of like it when that happens because at that point we're just done. Okay? So let's take a look at the next one. So this one says solve the triangle, and notice again we're given angle beta, a side, and a side. And again, think about how those would have to relate. This one is across from beta, and this one would have to be one of the ones next to it. And again, I find that this is just easier. Most people can draw these right triangles pretty well. So let's take a look at this one. Again, we're going to draw a long horizontal side. We're going to draw that angle roughly to scale. So draw the acute angle roughly to scale. So 38 degrees, something like this. So this would be 38 degrees. Might need to extend that out just a little bit. Let's see, this is beta, so B is going to be across from it. 6.4 is going to be over here. That means this is 5.9, okay? Now, I'm going to just blindly go through this list. I want to figure this out. I want to know what h is. It's going to work this way every single time. It's going to be this hypotenuse times the sine of that angle. So that's going to be 5.9 sine of 38 degrees. Okay, again, set it up like this. So we'd have the sine of 38 degrees. That side right there, the opposite side, height there, over 5.9. So we just multiply both sides by 5.9. So let's figure out what that is. And I'm hoping that you've caught on to what's going on here. So sine of 38 degrees. Okay, so it's got to be 3.62. So this is, and I'll go ahead and erase this. This is 3.62. Well, side B, the one that's across from the acute angle, is 6.4. Well, let's draw that roughly to scale. Here's about how long it would be. It'd be longer than that one right there. So again, you don't have the option of swinging over here. You've got to swing it over here. That's the only way it could be. And we could have spotted that to begin with. We could have said, well, wait, this is 6.4. How does it compare to the adjacent side right here, the one that's next to it? Well, it's a lot longer. So the only option for this one is to swing it out in this direction. Okay, that height didn't even matter. You can swing it out here, and this is 6.4. So I've got this angle corresponding to this side right here, and what I'm missing is I'm missing this angle right here. If that's 5.9 and that's C, this is going to be gamma. So let's find side gamma, or angle gamma. So I'm going to do the sine of gamma over 5.9 equals, and then let's see what I've got here. This is going to be the sine of, so notice we've got our angles on the top, sine of 38 degrees over 6.4. And then we'll just solve this. So you'll notice that what we get here is sine of gamma 5.9 sine of 38 degrees over 6.4. And then that means that gamma is going to be equal to the sine inverse of 5.9 sine 38 degrees over 6.4. Okay, so let's use the calculator for that. Slide this over here, clear this off. We're in degree mode, so we're in good shape there. Again, 5.9 sine 38 degrees, close the parentheses, divide by 6.4, hit enter, and I get 30.5 degrees. So 30.58, all right? So this is 34.58 degrees. Okay. So I've got that side, that angle, and that angle. I can do this one by subtraction. That would be just fine. I probably would want to make sure that I do that on the calculator. So let's do, let's see, let's do 180 degrees, and then we'll subtract 38 degrees, and then we'll subtract that last answer right there. So I don't get any rounding or anything like that. So I get 107.4, well, let's see, that would round up, so that's going to be 107.42. So 107.42 degrees, okay? And that matches up there. And now I need to find this one right here. Now, again, we'll run into this a lot with this textbook. It likes to round. I'm going to keep that exact answer in the calculator. We're going to use it as 107.42, but we'll make our calculations with this. So the only side that I'm missing here is A. So I'm going to have A on the top, sine of 107.42. And again, you'll remember this is a pretty easy one. Again, I'm not going to use this one right here. I'm going to use this one right here. So we're going to do 6.4 sine 38 degrees. Multiply both sides, so I get A equals 6.4 sine 107.42 over sine of 38. And we'll type that into the calculator again using that answer right there. So I get 6.4 sine of that last answer. Just recall that. And then we're going to divide by the sine of 38. Okay. Hit enter and we get 9.0 9.918, so 9.919, okay, 9.919. All right, now that's the angle that we found along with that one, and that was the missing side. So we had angle, side, side, had to be really careful with that. We found two other angles, and we found that last missing side. So that's how we do that one right there. Now, just a word about the way your textbook handles these. Again, it's going to round, and depending on the size of the angle and the sides, you know, rounding a tiny bit can make a really big difference. So if you're convinced you've done it correctly and the answer is off, you know, half a degree or something like that, you're probably okay. If they're larger sides and smaller angles, you know, sometimes, you know, they can even be off a degree or two. But this book rounds. If you want to go ahead and round to the 10th, just realize that that's, you know, it's really a horrible idea here. So anyway, let's pick up with this one right here. We've got alpha, side B, and then side A. These two correspond. This one's got to be across from that one, so this one's got to be the adjacent side. So here's what we're going to draw. And I'm going to draw a little picture right here. Again, roughly to scale. So this is 41.2 degrees. This is the one next to it, 10.6. What we notice right away is that this side over here is not bigger than that one. So let's check and see how long this one has to be. Okay, in other words, what is h? And that's always going to be this side right here, 10.6 times the sine of that angle right there, 41.2 degrees. So we'll type that into our calculator, and let's see what we've got. 10.6 sine 41.2, hit enter, 6.98. So that one's got to be 6.98. And take a look at what we've got here. So it's definitely longer than that right here. We can definitely make a triangle, and it's not longer than that. So we can actually swing it two directions. We're going to swing it out this direction and then this direction, and I'm going to show you why. So over here, this is what I'm going to draw. Let's draw what it would look like if we swung it out here. So that's what we're going to have there. And let's go ahead and solve this. So this is going to be 41.2 degrees. This is 10.6, and this side over here was 8.1. And let's find this angle right here. Again, that was side B, so we're going to find beta. So the sine of beta over 10.6 should be equal to the sine of 41.2 over 8.1. All right. Okay. Now, that means beta is going to be equal to, let's see, I'll write sine of beta here. We won't skip too many steps. 10.6, let's save some space here. 10.6 sine of 41.2 over 8.1. Now, the reason I saved space there is how am I going to get beta by itself? Well, I've got to take a sine inverse of both sides, right? So sine inverse here and sine inverse of this stuff right here. So here's what beta is going to equal. Beta is going to equal the sine inverse of that right there. Now, let's go ahead and find that on the calculator, and then we'll talk about how we'd finish this off and what the other case would be. So we're going to have sine inverse 10.6 sine 41.2, close the parentheses, then we've got to divide by 8.1. Okay? So we're going to get 59.541. Okay? So 59.541 degrees. Okay. This is why we've got to do this side over here. So we've got 59.541. Why we've got to find that angle right there first. So let me come back to this diagram here and show you what happens. So if I swing this out here, that angle right there is going to be acute. I've exaggerated that a little bit too much, so we'll swing it out to right here. That is an acute angle, okay? If I swing it in here, this is an obtuse angle, all right? So what we run into is, let's draw this other case now. This is 41.2 degrees, this is 10.6, and this is 8.1. The problem here is sine inverse. If you think of the range for sine inverse, it will only give you angles in quadrant 1 and quadrant 4. So the only ones that would work in a triangle are this quadrant right here. It will not give you obtuse angles. So the way we find this obtuse angle is we take advantage of this. So I'm going to zoom into this right here. If I can find this angle right here, and remember, this side is 8.1 on both of them. Those two are the same. How does this angle relate to that angle? Well, this triangle is an isosceles triangle. Remember, the base angles of an isosceles triangle are equal. So if this is 59.4, whatever it was, this is going to be 59.4, whatever it is. And then how could we find this one right here? Well, if this is, and we'll slide this over now, 59.541, well, this would make a straight line, so they would be supplementary. So this one's going to be 180 minus that. So I'm going to take 180 degrees. We'll subtract that last answer. And there we go, 120.459. So this angle right here is 120.459. Okay? So once I have that, then you'll notice that in each case I've got an angle and an angle, so I can find that one right here. So let's go ahead and do that. So I'm going to take 180, and I'm going to subtract 41.2, and I'm going to subtract 59.541. So that means this angle up here is 79.529. So 79.529 degrees. Okay, and once I've got those three angles, I only need this side right here. I can set that up. Let's see which one was missing. This would be side C. So I could set one up for that. And then, well, I'll tell you what, let's go ahead and do that. Let's go ahead and solve for side C. Here's the ratio that I'd set up. C over the sine of 79.52 should be equal to, and let's use the ones that we were given originally, so where there's as little rounding error as possible. This would be 8.1 over the sine of 41.2. Okay, so pretend you can read that right there. And then we can solve that just like we did the previous ones. Let's do this one up here. On that one, we're going to have 180 minus 41.2 minus 120.459. And we're going to get 18.341. So this is 18.341 degrees. Okay, so I found those two missing angles, and now I want to find this side right here. Again, C over the sine of 18.341 should equal, we'll use the ones we have, 8.1 over the sine of 41.2. And let's see, so C would be equal to 8.1 sine 18.341 over the sine of 4.2. Grab the calculator and type that in, 8.1 sine 18.341, close the parentheses, divide by sine 4.2, close the parentheses. Oh, let's see, what's going on here? Oh, there we go. This is 41.2. That would be bad. We know that had to be wrong because we're looking for a pretty small side here, so I'm going to recall that. And 41.2. Now let's see what we've got. 3.86. Okay. Now let's compare that with what we'd get over here. We're expecting this to be the largest side, and if I were to solve that, I'd have 79.52 up there. So if I were to grab the calculator, and all I need to do is 79.52, and we'll put a 0 on there. Sine of 41.2 is on the bottom, and we get 12.092. We're expecting it to be the biggest side, and it does turn out to be that way. So that's the ambiguous case. where that side is a little longer than H, but not longer than this adjacent side right here. Again, solve for this one right here because your calculator will give you this acute angle right here. It won't do that one, not directly. You've got to do that subtraction from 180 like we did here. If that's 59.4, this one's got to be, sorry, 0.4 or whatever that was. This one's got to be 120 point something. So just keep that in mind. And now we'll take a quick look at a couple of other problems here. So there are a few problems where you really need to use your head. They really want you to think. So this is an angle, a side, and then a side across from the angle. So let's set this up, and you'll notice immediately that we run into an issue here. 130 degrees. That's 130. The side across from it is 8, and the side next to it is 10. So just take a look at that. That is the biggest angle. It's got to create the biggest side. Okay? So no triangle in this case. Wouldn't work that way. All right? Let's take a look at this one. Again, same type of thing. 130 here. The one next to it, let's put a 10 here, and then let's make this one 12. Now, this one you can have a triangle, and the nice thing about this is even though you're given an angle, a side, and a side, because this isn't acute, we know for a fact that these two have to be, because this is obtuse, we know these other two have to be acute. There's no way we could run into a problem where this is obtuse and this angle right here is obtuse. So this is not an ambiguous case. We can go ahead and solve it this way. So this is gamma here, C here. This is A, so this is going to be alpha, and this would be beta, and this would be side B. So let's go ahead and set this up, and let's figure out what alpha is. So that's going to be sine of alpha over 10. That's going to be the sine of 130 over 12, and sine of alpha would equal 10 sine of 130 over 12, and then take the sine inverse. So alpha is going to be the sine inverse of this stuff right here, 10 sine 130 over 12. So we'll type that in the calculator. Sine inverse, 10 sine 130 divided by 12. And we get 30, we have there 36.67. 39.67. Okay, and that would be angle alpha. So once we know that this is 39.67 degrees, we can then do subtraction to find the last one. 180 subtract 39.67 minus 130, and we get this right here. So beta would be 10.33 degrees. So I've got that angle right there. I've got angle alpha right there. And then, of course, I can use these and set up a ratio. B over sine of 10.33 should be equal to, and again, I'll use the sides that I was given, 12 over the sine of 130. And then I think you can finish that from there. Okay? Now, those are the basics behind these problems. But you do have some problems on your assignment, so what you're going to want to do is grab a piece of paper, because some of the problems, they're a little bit tricky, and they require a darn good diagram in order to get these right. So here's what we're going to do. I'm going to move this up. Let's see. I'll tell you what. I'm going to erase this right here. You can always go back and bring that up again. And we're going to read this, and we're going to draw a diagram here, and then we'll solve it on the next page, okay? So it says during a NATO exercise, if you don't know what NATO is, you probably ought to look it up, an F-14 Tomcat, so a jet fighter, left a carrier on a course with a bearing of 34 degrees. So we've got to understand that when pilots and ships navigate northeast, south, and west, this is 0 degrees, and they do it backwards from what we do in trig. Okay, they go in a clockwise direction. So if I say I'm heading with a bearing of 90, I'm heading due east. 180 is due south, and 270 is due west. And then we can keep track of our direction, again, always from north and going clockwise. So here's what happened. That carrier was right here. And what I would advise is every time they give you a bearing of like 34 degrees or 162 degrees or whatever it happens to be, draw a little set of crosshairs like this, northeast, southwest, little axes if you want to think of it that way, and then mark the course on there. So it's course with a bearing of 34 degrees. So 34 degrees would be about like this. Okay, so heads off right there. That is 34 degrees. Okay. Now, drawing this little set of crosshairs is actually going to be a huge advantage in just a second, so let's take a look at that. All right, and then they give us our next piece of information. It flew 400 miles, so we know this side right here is 400 miles, okay? Then it flew for some distance on a course with a bearing of 162, so it got out there 400 miles, and then it changed direction. So again, whenever you change directions, we're going to put a little set of crosshairs here. And the bearing is now 162. So 162 is just shy of due south, so it's heading off at about this angle right here, okay? And this is 162 degrees right there, that outer angle right there. Not this little sliver, not that little sliver, but that one right there, okay? So that's a bearing of 162 degrees, okay? So it heads out there. It doesn't say how far, and then it says finally it flew back to its starting point at a course with a bearing of 308. So I'm going to draw what 308 would look like over here. And sometimes you have to do this. There's 90, 180, 270. So about right there, that's a bearing of 308. So that gives us some idea. When he changed directions, he was heading back kind of to the northwest. So here's what we're going to do. Let's extend this line so it looks right. Let's draw our little set of crosshairs. And then remember, 308 degrees. So we're going to go all the way around. There's 90, 180, 270, and we're going to head back in this direction right here. So that's what the course looks like. That red triangle is the course, and this angle from here all the way around to there is 308 degrees. Okay? Now let's think about this for just a second. And what we're going to do is we're going to take advantage of some geometry and some parallel lines and stuff like that. So I'm going to change colors here to write down what else we know. So this little angle right here is 90 degrees. If I use 34 of them right here, that's going to leave 56 degrees in right there. So that's not part of the triangle, but it is that little angle right there. Now, think about this. This is north-south and this is north-south. So if that's 34 degrees, these are what we call alternate interior angles. And if you'll remember from your geometry class, alternate interior angles are congruent. So that's 34 degrees right there. Okay? Now, let's think about this little sliver right in here. If this is 180 degrees from top to bottom, from north to south, and we only used 162 degrees right here, that would leave 18 degrees right there. And now we're really getting warm. So there are a couple different things that we can do. We've got this entire angle right here. We've got that side. We've almost got this one right here. So let's think about this. 90 degrees here, 180, and 270. So it's 270 to right here. How many are left over of the 308? Well, this little sliver right here would be 38 degrees. So if that little sliver is 38 degrees, that makes this little sliver 38 degrees. So that means I can add the two of those together. And if I add 38 to 56, I get 94 degrees for this one. If I add the two of those together, I end up with 52 degrees right here. And let's see, I can do that one by subtraction, so let's figure out what's left. So this is going to be, clear that off, 180 minus 94 minus that upper angle right there, 52. So this one better be 34 degrees. So we think that one right there is 34 degrees. But here's the cool part. This one right here is 18 degrees. So that little sliver is 18 degrees with north-south. This one right here better be 18 degrees. So guess what happens if we add those three together? So I have 18 plus 38 plus 34. I get 90 degrees. So that's that 90-degree angle right there. So here's what I've got. Here's my picture. I've got a triangle. Draw it down here on this one. It looks something like this. This is 94 degrees. This is 400, in this case, miles. And this angle right here is 52 degrees. And this is 34 degrees. And what it says is, what is the distance, what distance did the plane fly on the final leg of the journey? It wants this one right here. If you think about it, we could solve for this other one over here. We'll call that one y. I want you to take a second and I want you to think about how we put this together, why this is the right triangle, and then go ahead and finish it off. I'm going to run through this idea again because you have several problems where we're given some navigation bearings. We want to make sure we've got this straight. So I'm going to go ahead and stop this. I'll come back and I will finish this problem up and go through the setup really quickly again for those that need it, maybe a little bit differently. So thank you very much. You really got enough that you could actually do the homework at this point. So you can go for that if you'd like to.